Okay, Pre-AP Algebra 4, Final Exam Review, Part 4. So for numbers 28 and 29, we're talking about arc length. So arc length, when we're talking about in terms of radians, is just equal to the radius times theta. So radius times radians. So in this case, we just plug in 17 for the radius times 5 pi over 4 for theta. And we go ahead and multiply through and then simplify if possible. So 17 times 5 is equal to 85. So we have 85 pi over 4, which does not reduce, so there's our area, 85 pi over 4. For number 29, same thing. So this time we have 8 for our radius times pi over 6 for theta. So that would just be 8 pi over 6, which reduces to 4 pi over 3. For numbers 30 and 31, we're going to find the area of the sector. So area is equal to 1/2 r squared theta. So we just plug in, so 1/2 times 12 squared times pi over 3. So that would be 1/2 times 144 times pi over 3. Now, half of 144, that's going to reduce to 72 times pi over 3. Okay, and then 72 is divisible by 3 4 times, so we're just left with 24 pi for the area of the sector. Okay, and then for number 31, we have r is 3, so 1/2 times 3 squared times our theta, which is 3 pi over 4. Okay, so that would be 1/2 times 9 times 3 pi over 4. Multiply that all through. That gives us 27 pi over 8, which is not reducible. So that's our answer. Now our last two problems, numbers 32 and 33, are graphing trig functions in terms of radians. So we look at the first one, we've got a cosine function. Okay, cosine functions are in the form y equals a times the cosine of b theta. Okay, where we take, to find our period, we take 2 pi and divide by b. So in this case, we take 2 pi and divide by 2, because our b is 2 right here. This is our b. Okay, which is equal to pi. So we have a period of pi. So one full period is pi. And in a cosine function, we begin and end at our a, our amplitude. Okay, so our amplitude is 2, or is a, which is 2. So that means that we start at 2, We end at 2. Well, our period is pi, so we look at pi on the x-axis, and then we're going to end at pi comma 2. Okay, and then right in the middle of that, at pi over 2, is going to be our negative amplitude. And our zeros are at the halfway points between those two. So we have 0 at pi over 4, and a 0 at 3 pi over 4. Okay, and then we can continue this pattern on as many times as we want. Okay. And that takes care of our cosine function for 32. Now our sine function, we have y equals a times the sine of b theta. Okay, works pretty much the same way. Our period is equal to 2 pi over b. Well, this time b is 3. So we've got 2 pi over 3. 2/3 pi is going to be our 1 full period. Our amplitude is equal to a, which is 3. Okay. Because we have a sine function, we're going to start and end each period at 0. And there's going to be a 0 in the middle. So we have 0 comma 0 is where we start. 2/3 pi is where we are going to end. So 2/3 pi is going to be somewhere right in here, in between 1/2 pi and 3/4 pi, probably a little bit closer to 3/4 pi. And then halfway in between that, we're going to have a 0. And then our amplitudes are positive amplitude because we have positive 3. Our positive amplitude comes first, is halfway in between. So that would be at 1/6 pi, pi over 6. Okay, which is somewhere right around here. And then our other one is down here at -3, halfway in between those. Okay, and then again we can carry this pattern on. So if we go 2/3 pi, so the next one then would be at 4/3 pi. So let's see, 4/3 pi is going to be somewhere right around here. Okay, and then another halfway in between. So somewhere in there. And then my positive 3 up here. -3 down here. Okay, and again I can carry this as far out as I want, but that's probably good enough. 2 full periods is good enough to show what this sine function should look like. Hopefully your graph looks a little bit better. My stylus doesn't always cooperate. Okay, and that does it for the final exam review.